Welcome, everyone. We're thrilled to have you join us. I'm Sirish. I lead product management for data analytics and BI. And I'm excited to kick us off this morning on the lakehouse architectures for the agentic era. I'll start by motivating why today's architecture doesn't work well for the future. And then my colleagues and one of our valued customers from Cadent will describe how we are reimagining the Google Cloud Lakehouse for the agentic era and how our customers are already deriving value from it. It goes without saying, the agentic era is upon us. Agentic AI is not just a technology shift. It's a strategic imperative that has the promise to reshape fundamentally every industry, every job, and every task. It's changing the way we work. But here's the core truth. To fully realize the potential of AI, we need to change and evolve our data platform. Our data platform needs to go from simple systems of intelligence to true systems of action. And this entails three shifts. The first is from just data to knowledge. The second is from reactive to proactive. And the third, crucially, is going from human scale to agent scale. And that's why earlier today, we were very excited to unveil the Agentic Data Cloud, which is the definitive system of action that bridges the gap between thinking and proactive doing. Now, the Agentic Data Cloud is built on three core pillars. It is AI native, which means that we have integrated everything from the chips, the Gemini model, down to the data layer, resulting in unmatched performance and scale. Second, it's flexible. Any data, any format, anywhere. Your data could be in Google Cloud, it could be on-premises, it could even be in AWS. And the third is it's trusted. And by that, what I mean is it's built on the most comprehensive knowledge catalog foundation across Google Cloud and beyond. Now, this vision starts with the storage platform. You, our customers, are already building incredible agents. But we are hearing your feedback loud and clear, which is that your traditional lakehouses are falling behind. They're falling short. And let's dig into why current architectures are unable to keep up in the agentic era. And there's 4 reasons. The first is that traditional lakehouses were built for structured data. And they don't really treat unstructured data as first-class citizens with native AI capabilities. And so what this really means for your AI agents is they're not able to reason on your entire corpus of multimodal data. Text, images, audio, tabular data, log streams, time series. And this is a big limitation for AI, if it's not able to process all kinds of data that you have in your enterprise. The second one is that while traditional lakehouses and other vendors will claim to be multi-cloud, the truth is they don't really have cross-cloud interoperability. And by that, what I mean is that they may not be able to access data in other lakehouses or in other clouds, or if they do, it's with a TCO or performance that frankly just doesn't work for your applications. The third issue is trust. Context is absolutely vital because it's make or break for the quality of your agent's output. But traditional data lakehouses use a passive data catalog, which is not actively enriching and distilling business context and keeping it up to date. And this means that your AI agents suffer from loss of accuracy. And the last bit is when your analytic systems and your transactional systems had different storage silos and they're burdened by ETL, then your AI agents cannot serve up your analytic data with the low latency that your applications need. So 4 big gaps in why traditional lakehouses don't scale to the agentic era. So what does a lakehouse in the agentic era look like? We believe the next generation of lakehouse, the agentic lakehouse, should deliver on 3 non-negotiable promises. Openness without compromise, which gives you the ultimate flexibility of being completely open with all the power and governance you'd expect from an enterprise analytics system. Second, true cross-cloud interoperability, where you can run any workload on any cloud with the same compelling TCO and performance as if all of your data was in a single cloud. And the third is trust. Your lakehouse must deliver relevant, timely, and accurate context that all of your use cases require. And to better align our products with this vision, we are evolving Big Lake into the Google Cloud Lakehouse. The Google Cloud Lakehouse delivers on each of these promises. It's 100% Iceberg compatible, and it, under the covers, has the decades of innovation that we have that allows you to have unmatched price performance on analytics, as well as native AI processing for both structured and unstructured data. It's truly cross-cloud in the way that I just mentioned, and it's trusted because it's built on the knowledge catalog. Let's dive into each of these and how we build them. Please welcome Pratibha Suryadevara, VP of Engineering at Google.
Thank you, Sirish. Hey, over the next couple of minutes, I'll walk you through the first pillar of our lakehouse architecture. How do we build lakehouses which are open and we are not compromising on openness? Iceberg has now become the de facto standard. We've seen an explosion of adoption on GCP of Iceberg. Over the last 12 months, we've tripled the number of customers who are using Iceberg on GCP, and now we are managing about hundreds of petabytes of data, Iceberg data on GCP. Why this shift? Why suddenly everybody's excited about Iceberg? I think customers tell us they love the interoperability, they love the simplicity of Iceberg. Not only that, Iceberg has broken the data silos that we are used to, and the reality of convergence of data and AI is what Iceberg is driving. We have been very busy shipping at incredible pace to deliver the core foundations of a next generation Iceberg. First, we've boosted the performance and scale by launching managed Iceberg. We've advanced runtime environment for BigQuery, and not only working on the performance, we made ingestion into the lakehouse simple by supporting DTS into the lakehouse. Secondly, we spent a lot of time unifying the management and governance. We've launched the Iceberg REST catalog, we've launched the table management, we've launched a BigQuery object table that makes the processing of multimodal data very simple. Finally, we've unified the analytics and operational engines together. This is very exciting. Now we have AlloyDB and Cloud SQL able to replicate data into Iceberg, and it's also able to do change data capture into Iceberg. Not only that, Alloy is now able to understand Iceberg tables natively, and Alloy has also launched multi-table transaction support. This kind of foundation is actually enabling our enterprise customers to transform their businesses. Let me walk through a few of those examples, starting with HCA Healthcare. HCA Healthcare, before they leveraged this architecture, using this architecture, they brought in their structured, unstructured, and semi-structured data together into a single multimodal ecosystem that's enabling them to do advanced security, advanced analytics on their massive, massive data that they have from their clinical trials and operational data sets. And this is enabling them to deliver a very differentiated outcomes and experiences for their patients. The second example I want to talk about is Spotify. Spotify was able to democratize all their data and break down the silos between their data lakes and warehouses using this architecture. They've created an interoperable, abstracted out storage interface where they're able to get BigQuery, data flow, and a lot of open source engines processing the data in a single lake without any duplication of the data. This architecture simplified their governance hugely and enabled innovation at scale, which they would not have been able to do without. The last example, again, an incredible example of how UKG is using this architecture. UKG today, before this architecture, was managing about 7,000 individual customers, each of them using their own AlloyDB instance. The challenge they were having is, how do I consolidate data from all of these data silos? Because they were trying to get industry benchmarking and AI-powered payroll insights into this data. By leveraging this unified architecture, UKG was seamlessly able to move from thousands of their AlloyDB deployments, the data into BigQuery, and BigQuery was able to do cross-tenant analysis. But they didn't stop there. Now they use Alloy to serve all the BigQuery insights back to their applications at a very ultra-low latency that is powering their feature engineering and also AI experiences for thousands of their customers. All good examples. We've built the foundations, we worked on performance, we worked on governance, we worked on bringing the analytics and transactional engines together. But all of you are telling, hey, we see this, but for these advanced use cases, we are still doing heavy lifting of what needs to be done to bring our applications into this lakehouse, right? The first thing I hear from customers is, the real-time processing is still very complicated. I am still managing these complicated Kafka partitions, a lot of do-it-myself infrastructure that I need to bring in if I have to get zero staleness for my data. Two, the governance of this is very fragmented, right? You actually want data catalogs that are resilient at scale. You want a security model that is consistent, independent of the engines that you're running in the lake. And also the governance model should be consistent and not dependent on the data formats that you're using. And finally, the runtime environments that you need for the agentic era is very different. So I hear from customers on, hey, how can I use these engines to do multimodal processing? What can I do? How can I use this data in the lake to actually ground my agents? Industry has tried to solve this problem, but while they were trying to solve this problem, they've built these walled gardens. So now it becomes a choice for you. Should I use these advanced capabilities and give up my openness? But the approach that we did in Google was fundamentally different. In Google, we went with a vertically integrated approach that delivers enterprise differentiation for you while retaining openness. Let me walk through what the approach that we took on solving these challenges. Let me start with the real-time processing. We made the real-time processing seamless by launching read-write interoperability across engines, multi-statement transactions, high-throughput streaming ingestion, and change data capture replication. Two, how did we solve the fragmented problem that we had for governance? We've launched table management, we've launched table-level access controls, and also lakehouse governance. Last, about the runtime environments, both in BigQuery and Spark. Let me start with Spark. We launched Lightning Engine on Spark that will give you differentiated performance. We are using all the metadata that we have inside BigQuery to give you the performance that you need for your AI applications and multimodal processing. So let me dive a little bit deeper into each of these, right? Let's start with, firstly, we started with true cross-cloud interoperability. This means a seamless read-write capability between BigQuery, managed Spark, open source engines like Flink and Trino, all hitting the same data without any friction. Next, we've introduced multi-write capabilities. Our unified tables in the lakehouse support concurrent write operations across Iceberg-compatible engines, which is fundamentally solving the single writer problem. Finally, we've built an AI-optimized Iceberg storage. Leveraging the GCS Rapid, now you can get high performance, low latency access to the data inside Iceberg, ensuring you get the infrastructure for what is needed for your high demand modern AI workloads. Next, we worked on world-class BigQuery Iceberg experience. The enhanced metadata that is available is highly scalable and real-time, and we enabled that on the Iceberg. Second, the multi-statement transactions on Apache Iceberg give you the consistency that you need when you're doing multi-statement transactions across tables, multiple tables. The high-throughput streaming ingestion gives you the zero read latency. You don't have to wait for data anymore, and staleness is not a problem anymore. Lastly, the replicated data from operational databases into Iceberg tables using managed data streams gives you the latest data for your applications. Continuing, how did we make a scalable, secure management and governance? We've launched the lakehouse catalog that is end-to-end, has information for end-to-end lineage, data quality, discoverability, and business context. Automatic table management, so you don't have to worry about the primitive table management functions, and the same table level access controls across all the runtimes. The last one, let me talk a little bit about what we have done for the advanced runtime in each of the engines so that will enable native AI processing for you. I briefly talked about what we did with Lightning with Spark. Today, Lightning with Spark gives you 4.9x performance compared to open source Spark. BigQuery, I briefly touched about what we did with enabling CMeta inside the lakehouse, gives you the performance that you need to run your complex analytical workloads without requiring any user action. Bringing all these engines together, now you have a developer environment where you're able to interoperate between your SQL and Python very seamlessly. And the last piece is about the object ref inside BigQuery that is available in Lakehouse that will let you look at both structured and unstructured data and do the multimodal analysis that you need for your AI applications. With that, let me hand it to my colleague, Gaurav, Director of Product, to walk through the next two pillars of the Lakehouse.
All right. Thank you, Pratibha. It was great to see how our customers can now get the best of open and enterprise grade combined together. Now, if you are a part of an enterprise today, you are very likely living in a multi-cloud reality already. And if you have tried to stitch this data together across clouds, there are two common failure moments that we are constantly hearing over and over. Number one is that performance is really a bottleneck because of the cross-region, inter-region latencies. The performance doesn't really scale. And when it comes to cost, egress can really make the economics of the solution non-viable. These are important problems. When agents need to orchestrate data across different cloud boundaries, they need a seamless cross-cloud foundation that can scale with their reasoning needs. And this is an important moment for us because not only many of you are already multi-cloud, but many of you are actively choosing Google Cloud for its AI capabilities. Yet, your data can be on other clouds. This is why we are committed to innovating on your behalf. And we are making major strides forward to give you a GCP native-like experience for your cross-cloud data. Earlier today, we announced Cross-Cloud Lakehouse. This is a completely new way to approach cross-cloud analytics. And it's built on two key foundations. The key innovations powering this are, number one, a high-throughput, low-latent connectivity from GCP to your cross-cloud data. Number two, innovations in cross-cloud caching and processing that dramatically reduce the egress overheads giving you scalable economics. The net effect of these innovations is that you get native price performance as if you are local to the cloud, but you get it for your cross-cloud data, enabling the range of use cases. Now, high-performance access is one key aspect, but many of you have your data managed in foreign catalog. This is why, building on this high-performance foundation, we are now enabling a host of catalog federation capabilities. Powered by Iceberg REST catalog standards and other open standards for federation, we can now enable you to access your data managed in other providers in other foreign catalogs for data that's stored on other clouds. This makes it really, really easy for you to not only connect to your data, but actually access it in a high-performance manner. A great example of that is the SAP BDC integration with BigQuery. BigQuery can now access all of their SAP data, and you get a zero ETL experience in a high-performance manner to build the 360 use cases that you need for use cases. Similarly, this integration works in the other way as well. So if you are an SAP user, you can consume your data from BigQuery and use that to power your SAP experiences. Another great example is the similar integration with Salesforce, where zero-copy capabilities powered over a high-performance multi-cloud foundation enables you to build a host of customer 360 use cases, bringing all touch points that you have with your customers together to power the next generation of agentic use cases. And we have a growing, expansive partner ecosystem at all layers of the lakehouse stack. Whether you have your data in Snowflake, Databricks, or with other providers, you can now get bi-directional interoperability on this high-performance cross-cloud foundation. Or whether you're using dbt, Atlan, or other tools to orchestrate, manage, and ingest your pipelines in Lakehouse, they are completely compatible with Google Cloud Lakehouse. You can just bring your favorite tools over and work with Google Cloud Lakehouse. We'll continue to expand the ecosystem and partners in this area. Accenture is already leveraging these zero-copy integrations to connect the dots between data points within an enterprise across SAP, Salesforce, Snowflake, Databricks, BigQuery, to really create a comprehensive view and power the next generation of agentic AI applications. Now, speaking of agentic AI, many of you have been thinking about or talking to us about how do I actually take all the data in the lakehouse and build agents that work in real world, that can go to production. And as we think about that use case, there are 4 key problems that really come up. We have architected from the ground up Lakehouse to be designed for this agentic era. The first question that many of you are asking is, well, I did all the work to put high quality data in the Lakehouse. Why aren't my agents giving relevant responses? And as many of you already know, data is good, but context is what makes the difference. If you have high quality data, but you're if you're not passing the adequate context or the just right context, your agents can miss the response. Too high a context or too little a context, they're all sensitive drivers to making sure that your agents can optimally respond to the questions that your users are asking. This is why we are finding out that context that stays as tribal knowledge within your enterprise. Now, if you think about what that context is, it's first of all, it's about understanding the data natively, whether it's data in Google Cloud Lakehouse, whether it's data in federated sources, whether it's structured, unstructured, or operational or analytical, we are mining metadata from all of these places, distilling down the metadata, helping you understand the graph of that, and giving the knowledge catalog an ability to understand all of your data. But that's only half the solution. You can know the data, but it's really important to know how that gets used in enterprise. This is where your query usage logs are super critical, because we can now look at that and understand that when you ask about what's my revenue, you're actually asking for net revenue, not gross revenue. And we take this paradigm together, we bring all of that data, including any semantic model that you might have already built, like LookML, to bootstrap and create a knowledge graph within the catalog. These relationships are then associated and then made available to whether out-of-the-box agents that we provide to you, or whether it be third-party agents that you are building. so that your agents always get the right context and your accuracy and relevancy goes up, enabling you to build real-world use cases. Now, context is really important to get high-quality responses, but it's also equally important to get this in the context of right governance. Your agents cannot have unfettered access to your enterprise data. It needs to work in the governance framework. This is why we are launching open lakehouse governance for the lakehouse. Your users can now access all of the data in a headless permission model. All of your permissions stay in the catalog, and when your agents access the data, they are only entitled to see what they are given access to. Even when they search, they can only search for the objects that they are given explicit permission to. And to give you even more control, we are launching data products where you can explicitly define boundaries for your data, where your agentic use cases can be tied to, and limit the access to your data. Governed access to your data with the right context is a huge unlock, and Lakehouse provides these capabilities out of the box. But there is also a third class of problems. How do I get started right away? And this is where we are reinventing the developer experience. So our Lakehouse automatically gives you out-of-the-box pre-built agents. You get a data engineer that's helping you build production-grade pipelines. You get a data scientist who is helping you write great pipelines and modeling and training together. And you get conversational analytics for your business users who can get insights from multimodal data, really combining structured and unstructured together and giving you 360 insights across all your data estate. If you want to build your own agents, and if you are developers, we are taking one step further with extensibility. We are taking the best practices that we have seen with our first-party agents and productizing them as skills and MCP tools for you to integrate in your workflows. You can take these data cloud agentic skills and use that to build your own custom agents. We're not only giving you these skills, but we are giving you these skills integrated in the ecosystems you already are. So whether you're using any VS Code-based extensions or platforms, whether you're using Cloud Code, whether you're using Gemini CLI, you can now run all of these skills and MCP tools within your tools. You also get the flexibility to choose the models you like to orchestrate your data workflows. This makes the developer experience really, really seamless and AI first. There is another class of use cases we are hearing from you, which is, how do I take a data agent that works within my enterprise and turn it into a customer-facing agentic application that scales to millions of users, serves responses at very low latency, and provides very high QPS? To make that really easy, to build that over your Lakehouse data, we are deeply integrating Lakehouse with our operational databases. We are bringing AlloyDB as a first-class citizen into the Lakehouse so that you can do a one-click reverse ETL in real time for your data to be served from AlloyDB for powering your agentic applications. These capabilities put together not only make the Lakehouse enterprise grade, but ready for agents. To tell you more how these capabilities are powering the agentic transformation for Cadent, I would love to invite Sowgandhika Dusa, who is the Chief Data and AI Officer at Cadent. Thank you.
All right, hope everyone's not agent overloaded. We have 2 more days. All right. So we are standing at the dawn of what many are calling as agentic era, where AI agents work alongside of us, understand our questions, proactively try to find answers in your data. But there's a critical question in here, right? Is your data ready? Is it organized, unified, and open enough for it to make sense out of it? Well, my name is Sowgandhika, and at Cadent, we had this exact challenge, and today I'm excited to share our journey of building our lakehouse, a data lakehouse that's ready for the future. So before getting into our journey, it's important to understand who Cadent is. We operate at massive scale in advertising industry. We connect over thousands of advertisers and agencies with hundreds of publishers, processing over 143 billion impressions tied with predictive scoring every day, and processing over 22,000 custom predictive models. It's really massive. And our history has shown a strong evolution. We started with strong foundation in video in 2016 and strategically grew through acquisitions. Just in the last 3 years, we acquired 3 companies. So this transformation and evolution has moved us from a CTV-centric company to a fully omni-channel advertising provider with deep expertise in predictive and AI capabilities for advertisers. Now, this transformation has also posed a significant challenge. We had our data ecosystems that are ever-growing, technologically diverse, and fragmented. Now, these are the core Cadent solutions that we offer: predictive intelligence, Cadent Audience, Total Video, unified digital, geointelligence, creative intelligence. Independently, these are very powerful, but together they form this connected system that drive performance and efficiency across all media. Now let's look into our journey and how we build this lakehouse that's supporting our challenging and ever-growing business. This is what I call our before state, our fragmented data realm. As I said, Cadent is a company of, we are a company of both acquisition innovation, but also product innovation. So every company that grows through acquisitions, or even like merging your teams internally, dreams of having this synergy and combined strength, but what you really get behind the scenes is this fragmented kingdoms of data spread across multiple islands with its own language, with its laws or treasuries, as I call it, logged in. And at Cadent, this is how our acquisitions and growth has posed a challenge to us. Our data is spread across multiple continents and islands, as I would call it. As you can see, we had like different local data stores, data warehouses, data lakes, across multiple clouds as AWS and GCP, analytical stores, all very fragmented, and it was really difficult for us to get a global view of our business in one place. So we knew we could not build a future on a fragmented foundation, right? So it was really important for us to unify our kingdom. And our approach was a bold 2-part strategy. Part 1, we built a new capital for this United Kingdom. That is the Google Cloud. So we embarked on a massive migration, a strategic massive migration journey of moving all our platforms onto one data platform. And this wasn't just a lift and shift. It was really important for us to have one center of gravity for all our data kingdoms. And then second is we built a modern treasury and library for this capital, and that is our enterprise lakehouse. What this really meant for Cadent is we worked on core foundation principles for building this Cadent lakehouse. We unified on strong foundation on GCS. We used Apache Parquet as our file formats and utilized Apache Iceberg. I guess this is a game changer, and I call this as a citadel of the core kingdom in here. So we moved from this, our goal was to move from this fragmented data realm to this unified enterprise data realm, which really helped us achieve these objectives of having a foundational data store, all this, the robust governance, faster innovations, and great stuff we talked about. And this entire migration, which is pretty massive for what we're talking about, we were able to migrate all of this in close to like 9 months of time, which I think if I were to look at from my previous experiences and working in multiple clouds, it would be a close to two plus years project, but we utilize a lot of AI along our way, automations for code migrations, code validations, code testings, data pipelines validation. So again, we're building on top of it, and there's a lot of learnings along our journey. Now let's look at our architecture. This isn't just a theoretical architecture. Its systems operate at massive scale. We operate over, we process more than 1,400 terabytes of data and 3 billion events across our 3 platforms every single day, and over 2,000 active machine learning models. So these numbers highlight why it's really important for us to have a unified and scalable architecture. Is not just a nice to have, but it is an absolute business necessity for us to have this unified lake. So looking into the architecture and taking you guys from a bottom up, layer one, we standardized unified our data on Google Cloud Storage, standardized on columnar files with Apache Parquet. Layer two, we adopted open table format with Iceberg. So this really allowed us that flexibility and open standards with ACID transactions, table versioning, and schema evolutions directly on the data lake files. And step three was we built governance directly into our platform using Google's Big Lake Metastore. Let me see if I get this right. The new term for Big Lake Metastore is Lakehouse Runtime Catalog. There you go, I got it right. All right, so this is allowing us to have a universal data catalog and enabling us to have observability, lineage, and traceability across all our data. Layer four, this is our unified semantic and query layer, where all the business users with BI dashboards to the technical users with Spark Engine, Spark jobs, are all able to access this governed unified layer using tools like BigQuery, Spark, DuckDB, and we have many such tools out there. All right, this is where it all comes together for agentic era. This isn't just a repository. This is a foundation of building intelligent agents on top of it. So again, taking from a bottom up, layer four, this is our unified foundation where all our data is living with data lake, GCS, BigQuery, and Bigtable as one source of truth. Layer three is the agents tool where agents have specified tools to access data from the foundation. It could be a BigQuery tool to access structured data in BigQuery, or it could be a vector search accessing unstructured in GCS, or a Bigtable tool to access low latency lookups. That's all happening in this layer. Layer two is the actual agent brain. This is the orchestration and reasoning layer powered by Gemini on Vertex AI, built by using MCP or ADK, where it takes users' queries as natural language and processes it and intelligently identifies the right agent tool from layer two and accesses the foundation. And layer four, this is where it's powering all our products, all the way from our agents, inbuilt agents like campaign optimizers or audience builders to reports and analytics. This is really allowing everybody to access data conversationally. Now, the big question is, what is the tangible business outcomes of this unified architecture? Number one, we are able to achieve flexibility and interoperability by using open table formats with Apache Iceberg. We standardized on data, not tools. What this means is our engineers are able to get any engine to get the job done, be it BigQuery or Spark or Python. You pick it, and this truly gave us the flexibility to get the job done. Number two, we've truly unified, had a unified foundation. We've broken down the walls between data lakes and data warehouses, right? What this means is all our structured, unstructured, semi-structured data, analytical stores, operational data, all of this data is all living in one unified ecosystem for everybody. Number three, this unification has truly democratized our access. What we mean by this is all our teams and tools from BI to AI are able to access this data from one single source of truth. And finally, this is setting the stage for us to innovate and accelerate faster, bring AI solutions faster to the market for Cadent. So that was our journey of building a lakehouse ready for the future. Thank you.